All right, so last time we took a look at kind of an easier problem while applying those 3 levels of answering a coding interview question. From level 1, you have no coding knowledge, and up to level 3, where you do have some coding knowledge. So let's go ahead and jump into this. We're back on LeetCode. We're going to go to top interview questions, and let's scroll down to a medium problem here. We'll take a look at maximum subarray. Okay, so the first thing that we want to do, obviously, is let's go ahead and read the question and see if we can understand what it's asking. So given an integer array nums, find the contiguous subarray containing at least one number, which has the largest sum, and return its sum. So we don't have to return the array here, or the subarray. We just have to return the largest sum. So level 1, we want to be able to actually solve this on paper first. So if we go ahead and take a look at example 1 here, we're given our nums list, and what we can do is first, I guess, go through the list and then go through the remaining list and add up all the possible subarrays. So for example, we can start here at -2. So -2 is our current sum at this point because we haven't seen anything else. Then we can take a look at this subarray, -2 plus 1, which is -1. So -1 is greater than -2, which was the previous subarray. So now we can, hold on to that value. And we can go through and continue going through, checking each subarray's value until we get to, this target output here. And then after we've gone through this entire subarray, then what we do is we move over and we start checking this subarray and going through all of this here. So for level 1, let's go ahead actually, and what we can do is kind of make some comments to ourselves to figure out exactly what we're doing here. So something that we wanted is we want a way to, I guess, figure out what our current sum is, or our current answer. So we can say something like, current sum. And essentially what this is going to check, or maybe a better way to call this would be something like largest sum. Because this is the largest sum that we've seen so far. And what I mean by that is if we start here at -2, -2 is the largest sum that we've seen so far in this subarray. But if we jump over to now considering this subarray of -2 and 1, now -2 plus 1 is -1. So largest sum would need to be updated to -1. So we want to, let's say, we want to keep track of the largest sum that we have seen. And ultimately what we're doing is we want to go through the list and then go through the remaining to grab all these subarrays here. So what we want to do, go through the list, then we can say and go through, oh wow, there we go. Go through the remaining list to find all possible subarrays. Okay, perfect. So let's see, we want to go through the list and then go through the remaining to find all possible subarrays. And while we're doing that, we want to keep track. So we can also make another line here. We can say and keep track of the current sum. Okay, so this is level 1's solution here, because let's try it on example 3 here. So we want to keep track of the largest sum that we have seen. Okay, perfect. So I have that in my head. Largest sum we've seen so far is nothing at this point because we haven't gone through the list yet. Then we want to go through the list and go through the remaining to find all possible subarrays. Okay, so we'll go through the list here. So we'll start at 5. And we want to keep track of the current sum. So the current sum I'm seeing here is 5. And if I consider 5, 4, current sum I'm seeing here is 9. And then we continue going on and on, iterating through this entire list until we see the largest subarray, which I believe at this case would be the array itself, which would give us that output of 23 there. Yes. So now, level 2, we actually want to implement our level 1 solution. So this here, we want to keep track of the largest sum that we have seen. So because we want to keep track of that before we actually get into this nums and start considering this here, that actually lets us know that this variable will exist outside of our loop here. So we can call it, well, I've already called it here, so largest sum, and we can set that equal to, let's see, what is the smallest value, I guess, possible? I guess in Python we could do that. Or if you're not familiar with this, I guess minus infinity is kind of what this was referring to, a really, really small value. You could just pick something really, really tiny that you think won't exist in this array here, but that might lead to memory issues, so this might be a little more efficient. So now what we want to do is go through the list. So remember that go through the list, this wording here should always indicate to you a for loop is about to happen, or that a for loop needs to happen here. So once again, we can say for I in range, and what we want to do is actually go all the way to the length of the nums here. So we're going to go all the way and consider all of these possible values here. And once we have that for I in range, this starts actually right here. So before we go through the remaining list and even itself here, what we want to do is also keep track of that current sum. So what we can say is current sum is equal to 0 at this point. Then what we want to do is go through the remaining different combinations of that to find all the possible subarrays. So once again, that go through wording should indicate to you a for loop. So we could say for j in range, and we want to start at I here and then go to length of nums. So what that's meaning is for I in range here, so we start here at this index, and then for j in range, so now we're going to start here and go through all of this here, checking the possible combinations. Then after we're done doing that, then we implement or we increment I by 1, so then we are here. Then we go for j in range of I, now I is here, so then we go through this entire subarray, then we go through this entire subarray, and just iteratively we go through each and every single combination that we have here. So what do we do when we get into this condition here? So now we're right here. Well, our current sum at this point is going to be nothing but the current sum, which is, I guess, 0 at this point. But then we want to also add whatever the actual iteration value is, whatever that current number is. So we're saying current sum is 0 at this point here, and then we want to add whatever this nums is here. So 0 plus -2 is going to be -2. So now current sum is -2. Then if we jump over here, now it's going to be -2 plus whatever this is here. So it gives us the current sum of this here. And after we do that, we want to also figure out what's going on with our largest sum. So our largest sum is going to be something different here. It's actually going to be equal to the max value of whatever the largest sum is and the current sum. And so if we write that here and we go largest sum and then current sum, what this is saying is, so we want to update each of these variables here. So largest sum is very small and current sum is 0 at this point. So what we can do is current sum now, if we go here, is -2, and largest sum is the max of -infinity and -2. So now largest sum that we've seen so far is actually -2 as well. So after we've gone through all of that and our wonderful for loops here, now we actually want to return the largest sum at the end of this all. And let's go ahead and run this here. And you can see that it's going to be quite slow, but it is an accepted answer here. So this is level 2, which implements level 1's solution up here. If we want to take a look at kind of a more efficient way to do things, we're going to need to first remove level. I guess before we remove level 2, let's think about how we might be able to convert level 2 into a level 3 type solution. So something that we know we need is definitely going to be our largest sum and our current sum variables here. But what we can do with level 3, since you have this coding knowledge and this coding experience, is you might look at this and see, oh, maximum subarray, that's Kadane's algorithm. So I want to implement Kadane's algorithm. So what you could do now is actually go ahead and do that. So we'll still have our largest sum as our minus infinity here, and then we can say our current sum at this point equal to 0. And we want to declare these outside of this loop because we're going to be changing our loops here. So if we remove this now, and if we kind of just shift tab that, okay, so now instead of incrementing by the index, it might actually be easier to change our for loop to be for each number inside the nums list here. So for each number inside that list, which this num just refers to the current number, we want our current sum, which would be our current maximum in this case. So we want our current maximum to be equal to the max of the current num here, and then also of the current sum plus that num. And the largest sum is actually going to remain the same here. So it's still going to be the largest sum and then the maximum of the largest sum and the current sum here. And once again, we're still going to return the largest sum here. So if we run this now, we can see that we're much faster, and we also just have one for loop. So we're O of n time complexity. And I mentioned here that this is called Kadane's algorithm. And what I recommend is to look kind of the proof of why this works up. It's kind of a mathematical proof of why this works, and it's actually quite interesting. But here is kind of what level 3's solution would be. It's kind of your most optimal solution. So we've gone through level 1, which is you have no code experience at all the way to level 2, which is implementing level 1 solution, and then up to level 3, which is Kadane's algorithm for this particular solution. So hopefully you enjoyed that and this helped you out.